Assalamualaikum warahmatullahi wabarakatuh. This is our group video presentation for Math 183 Calculus 1 Optimization. This is our group members including myself, Alia Maisara, Anas, Umi and Shakiri.
Assalamualaikum, my name is Umi Naatika Akmal binti Alias. Introduction of Optimization. Optimization is the process of finding the maximum or minimum values, minimizing the cost of producing an automobile in light of certain known constraints on the cost of each part and the time spent by each laborer, all of which may be interdependent, would be a practical example. Regardless of the application, however, the crucial step in solving any maximum or minimum problem is expressing it in mathematical terms. And then where we use maximum and minimum problem, one of the inspirational factor in the development of the calculus in the 7th century was the problem of finding the maximum or minimum of function, which is encountered in geometry, mechanics, physics and other fields. Everything in this world is based on the maximum and minimum concept, and we always calculate the maximum and minimum of each data point. Results from NWDs are also based on grid concept, which are also based on the maxima and minima concept.
So, there are 4 steps on how to solve optimization problems. The first step is translating the problem using assigned symbols, variables and sketches when applicable by finding 2 equations. One is the primary equation that contains the variable we wish to optimize, and the other is called the secondary equation, which holds the constraints. Second, substitute our secondary equation into our primary equation and simplify. Next, we have to take the first derivative of this simplified equation and set it equal to 0 to find critical numbers. The final step is verify our critical numbers yield the desired optimus results, whether it is maximum or minimum value. While this may seem difficult at first, it's really quite straightforward, as we are simply finding 2 equations, plugging one equation into the other, and then taking the derivative.
Okay, optimization. The question that I get is 2C. A rectangular flower garden with an area of 45 meters square is surrounded by a grass border, 1 meter wide on the 2 sides and 2 meter wide on the other 2 sides as shown in figure 1. Let x and y be the length and the width of the flower garden respectively. So you can see at the figure 1, you can see at the figure 1. Show that the combined area of the garden and the border is A equal to 2x plus 180 per x plus 53. Since the area rectangular flower garden is 45, we have x multiply y equal to 45. Convert it to y equal to 45 per x. So the combined area of the garden and the border is x plus 4 multiply 2y plus 2 equal to x plus 4, and 45 per x plus 2. The y will be changed to 45 per x, and then you will get the equation. 2x plus 118 per x plus 53. So you can see from here, this is the same equation as given at the equation.
Next, I will discuss question 2. What dimensions of the garden will minimize the combined area of the garden and the border? Let's take a look here. In the picture, the flower garden is surrounded by a grass border with 1 meter wide on the below and above, and the other 2 sides have a 2 meter wide border. So, I'm gonna do some labeling. Up here is x plus 4 meters stretching from this end to the other end, while the height of the whole thing will be y plus 2. For the solution, we are trying to minimize the combined area, so the objective function will be a equals to the base of the combined area. So that will be x plus 4 times with y plus 2. Now, since we have two variables for the area function, we need to connect x and y. So we have to make a constraints, and it will be x times y equals to 45 meters square of the area. I will get y equals to 45 over x. Next, I will plug 45 over x into the objective function earlier. Finally, it will give me 45 plus 2x plus 180x to the power of negative 1 plus 8. From this equation, I take the derivative and I'm left with 2 minus 180x to the power of negative 2 equals to 0. And then I can get the value of x, which is equals to square root 90. For the last step, I need to know if I have achieved a minimum amount. So I'm gonna use the second derivative, and it will be 360x to the power of negative 3, which is greater than 0 for all the possible x. So the function a of x is always concave up. So it's clear that whatever critical number we found has to be an absolute minimal. Otherwise, this would not be concave up. After that, we have the value of x equals to square root 90, and the value of y equals to 3 times square root of 10 over 2. The final answer is 3 times square root of 10 meters times with 3 square root of 10 over 2 meters.
Assalamualaikum. I'm Anas bin Muhammad Akbar. So my metric number is 2020242668. So today I want to discuss question of math. So the question is, what is the minimum combined area of the garden and the border? So which is, the question is the minimum combined area of the garden and the border. So which is a is equal to x plus 180 per x plus 53. So we substitute x to square root 90. So that will be 2 square root 90 plus 180 per square root 90 plus 53. So the answer is 90.95 cm square. So the answer of the minimum combined area of the garden and the border is 90.95 cm square.
And after that, for conclusion, draw and label the following problems and determine whether they are minimized or maximized. And then solve the problem by using the first and the second derivative methods. Put the variables in the equation. Ensure that you verify the step and your solution. And this is the reference that we used to search for this knowledge.